Let's look at the midpoint of a line segment joining 2 points in the Cartesian plane. And here's the formula that the midpoint M of the line segment joining these 2 points is given by the following point. Notice what we are doing. We are averaging the x-coordinates of these 2 points, and that's the x-coordinate of the midpoint. And then we average the y-coordinates of these 2 points, and that's the y-coordinate of the midpoint. The midpoint is a unique point on the line segment joining these 2 points that's exactly halfway between them. Let's look at an example. Let's find the midpoint M of the line segment joining A and B. We'll then plot A, B, and M, and we will verify that indeed M is that unique point that is exactly halfway between A and B. Let's let this be x1. This be y1, this be x2, and this be y2. And so by our formula here, M is equal to x1 plus x2, which is -1 plus 5 divided by 2, and y1 plus y2, or 3 plus -5 divided by 2, which is equal to -1 plus 5 is 4, and 4 divided by 2 is 2, and 3 minus 5 is -2, divided by 2 is -1. So our midpoint is located at 2, -1. All right, so now let's plot A, B, and M. We're given that A is located at the point -1, 3. So x equal to -1 is here, y equal to 3 is here, which means this is the point A, which is -1, 3. B is located at 5, -5. So here's 5, and here's -5. So here's B at 5, -5. And we just found that our midpoint M is located at x equal to 2, y equal to -1. So M is right here at 2, -1. Now let's draw the line segment joining A and B. And looking at this line segment, it appears as if M is that unique point that's exactly halfway between A and B. But let's go ahead and verify that by proving that this chain of equalities here is satisfied. All right, so what is the distance between A and M? By the distance formula, this is equal to the square root of the difference in the x-coordinates squared, so -1 minus 2 quantities squared, plus the difference in the y-coordinates squared, or 3 minus a -1 squared, which is equal to the square root of -1 minus 2 is -3, and -3 squared is 9, and then plus 3 minus a -1 is 4, and 4 squared is 16. So this is equal to the square root of 25, which is 5. That is, looking over here, this distance then between A and M is 5. Now the distance between M and B should also be 5, but let's verify that. So the distance between M and B is equal to the square root of the difference in the x-coordinates squared, so 2 minus 5 quantities squared, plus the difference in the y-coordinates squared, or a -1 minus a -5 quantity squared, which is equal to the square root of 2 minus 5 squared, which is -3 squared, or 9, and then plus -1 minus a -5, which is 4 squared, or 16, which is equal to the square root of 25, which sure enough is 5. That is, this distance here is also 5, which means we verified this first equality up here, that the distance between A and M is the same as the distance between M and B. Now the distance between A and B should be twice that, or 10, but let's show that that's true. The distance between A and B is equal to the square root of the difference in the x-coordinates squared, so -1 minus 5 quantity squared, plus the difference in the y-coordinates squared, or 3 minus a -5 quantity squared, which is equal to the square root of -1 minus 5 squared, which is -6 squared, or 36, plus 3 minus a -5, or 8 squared, which is 64, which is the square root of 100, or 10. So sure enough, this distance here between A and B is 10, which means we verified this second equality over here, because 1/2 of 10 is 5. That is, M is a unique point on the line segment joining A and B that's exactly halfway between A and B. And this is how we work with the midpoint of a line segment joining 2 points in the Cartesian plane. Thank you, and we'll see you next time.